Alright, so vector equations are just another way to represent a line. So they're usually in the form of some x, y times t, where t is the time, plus, this is a different x, some point x and some point y coordinate. And of course this isn't actually a point, this is a vector. But for all intents and purposes, we can think of it as a point, because what it is a position vector, which is a vector which indicates position of a point. So like what I mean by that is, let's say we had the point 1, 2. We could represent it with the vector 1, 2, and these in your mind should be the same thing. It should be this point right here, regardless of whether we put the point there or we have a vector that points to it. And so for a line, we need a point and a slope. And you can kind of think of this as your starting point, one point that is definitely going to be on your line, and this as your slope. Because let's say our vector equation was 1, 1t plus 1, 2. So what this is telling us is that this line starts at the point 1, 2, and it goes up. This is what it should kind of look like. The slope of the line is 1, 1, because when t is 1, okay, when t is 1, we're going to be adding the vector 1, 1 to this point, okay? And so that would look like 1, 1 times 1 plus 1, 2, which is just equal to 2, 3. Which is what this point is, right? It's 2, 3. Or we can think of this as, and this line will go on forever, if t were, for example, -3, okay? So then our vector would look like -3, -3, if this is when t is 1, this is when t is -3, plus 1, 2, which would be -2, -1. Which, if we look right here, if we have t is -3, so we go down once, we go down twice, and this is down the third time, and this indeed is the point at -2 and -1. So this is kind of how we move up and down a vector equation. And so this is just another way of representing what we could in point-slope form, or in, y equals mx plus b. So what this is really doing is we're starting out at a point, a position vector, and then we're moving up by a certain vector, and t is the scalar that tells us how much we move up by, okay? So if we had, I'm going to do an example of it in a different color. So this is our vector, right? And it goes a certain amount, so it's always on this line, because it always has a slope of 1, 1, or the vector is 1, 1. So the direction is always going to be the same, but t dictates the magnitude. So when t gets bigger, so let me draw an arrow on the end of this. When t gets bigger, the the point is going to get further and further and further away, or t can be negative, and then t will go the opposite direction. So let me show that. If t were negative, it would still start at the same point, so it would start right here, except now the point is changing in this direction. So it could be any of these points on this line, but it just depends on what t is. It can't be off the line, it still has to be on that line, because the vector's direction is 1, 1. But it can be any point on the line, and it just depends, what t is.